Hello everyone, and we are ready to start the 12th of December at the Advent of Code. It's called Garden Groups, and we'll see what we got for that. As in previous previous stream, we were submitting the first part to one of the smartest models, like O1 or O1 Mini, and then after it's solved the first part, because it's usually like 100% of like O1 Mini or O1 has close to 100% of solving rate, as well as Claude 3.5 Sonnet, but last time Claude wasn't so good. So yeah, I'll be just to test all the models properly. I'll be just finishing with the first task with a smarter model, and then I'll submit both parts of the task. First part of this challenge. After we solve it, we get the second part, and I want the models to solve both problems at the same time, and that's how we'll figure out which one is the best. So let's firstly read it.
Why not search for the chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map, your puzzle input, of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching horizontally or vertically, they form a region. For example,
so we have some regions, some garden plots. We have A, B, B, C, D, B, B, C, C. This is 4x4 arrangement.
This 4x4 arrangement includes garden plots growing 5 different types of plants, labeled A, B, C, D, and E, each grouped into their own region. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area of a region is simply the number of garden plots the region contains. The above maps type A, B, and C plants are each in a region of area 4. The type E plants are in a region of area 3. The type D plants are in a region of area 1.
Okay, I see now. So we have like basically a letter is a square meter, 1 meter by 1 meter area, and so we go like how they arranged. We count number of letters. That's why we get number of square meters. This will be the area of the plant, of a specific plant of this letter. Yeah, what's next?
Each garden plot is a square and so has 4 sides. The perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. The type A and C plants are each in a region with perimeter 10. The type B and E plants are each in a region with perimeter 8. The lone D plot forms its own region with perimeter 4.
Perimeter, okay. Yeah, once again, because the size of each square meter, the side length is 1. Therefore, you get a perimeter over 1 square meter is 4, because there are 4 sides. If we have 2 square meters, 2 squares, then we add up like 1, 2, 3, 4, 5, 6, like that. So do we have 3 letters? No, we don't. Oh yeah, we have 3 E's. Type B and E plants in each region primitive 8. Okay, so Y8. Once again, 1, 2, 3, 4, 5, 6. Y8. Not sure. Let's see what we got.
Visually indicating the sides of plots in each region that contribute to the perimeter using. And ORS. The above map's region's perimeters are measured as follows.
So, let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3. Oh, I was counting 2, not 3. Okay. So for 3 letters, we get like 8. Perimeter of 8. For just 1 letter, we get perimeter of 4. For 4 letters, we get as many like 10. Okay, so plants.
Plants of the same type can appear in multiple separate regions, and regions can even appear within other regions, for example.
Okay, so there are X's inside these O's.
The above map contains 5 regions, one containing all of the O garden plots, and the other 4 each containing a single X plot. The 4 X regions each have area 1 and perimeter 4. The region containing 21 type O plants is more complicated. In addition to its outer edge contributing a perimeter of 20, its boundary with each X region contributes an additional 4 to its perimeter for a total perimeter of 36.
Yeah, that's because we count both inside and outside perimeter of this shape. What do it stop?
Due to modern business practices, the price of fence required for a region is found by multiplying that region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for every region on the map. In the first example, region A has price 4, 10 equals 40. Region B has price 4, 8 equals 32. Region C has price 4, 10 equals 40. Region D has price 1, 4 equals 4. And region E has price 3, 8
Multiplied by
is
8.
24. So the total price for the first example is 140.
I won't ask it to read. So in the second example, the region with all of the O plants has price, okay, and region at each small x with the price 1 over 4, like multiplied by 4, it's 4. For a total price, just summing them up. Here's the larger example. Okay, so we have. So the first thing we need to do is to identify the regions, the separate regions, and then just using their shape, count the number of letters that would be the area, and then to calculate the perimeter, we need something more complicated than that. So we need to look for the adjacent letters, and if they are, then we don't count the intersecting, like the not intersecting, but the part where they are adjacent, like the parts in the middle. We don't count as a perimeter. How do you check for adjacency? How do you check if they are like in a square? This type of adjacency? I'm not sure. So yeah, I have no idea how I would approach it. Day 12's input. This would be really interesting to visualize as well. But so let's see if like ChatGPT O1 Mini will solve it. Or do I have an access? No, I don't. So O1 Mini. Let's see. So what do I do? I paste the description. I'll paste the README. And by the way, I can just do it probably here. So O1 Mini. Let's select a model and a file. Let's add a README and let's add the description and then solve the first part. So it started thinking. Okay, so we have an answer for part 1. There is some interesting algorithm called BFS. Alright, let's see if this one solves it. Python O1 Mini. We get this number. No. Let's go into advanced code and paste it. Yeah, gold star. Okay, perfect. So now we let's read first the task 2 and then give all the models or both of the tasks, both of the parts to solve.
Fortunately, the elves are trying to order so much fence that they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is.
Okay, I see now. So now when we count the perimeter and we go one letter by letter, we won't count a straight line that contains like that's near 2 letters as 2 meters. We'll like consider it like a 1 meter or just one line. Therefore, we multiply the area by of that region by the number of sides it has, not by number of each pieces of the side of the fence. So the region containing a plants has 4 sides, as does each of the regions of other types. The more complex region has type C, has 8 sides because it's complicated shape and it has 1, 2, 3, 4, 5, 6, 7, 8. Using the new method of calculating per region price, multiplying by region area, number of sides, blah blah blah. It's the number is different. Second example again, just examples to understand it better. So like the map of E-shaped region full of E plants. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Where did I start? Like 12 sites, okay. 17 is the area and 12 sites. Price of 204. This map total price, okay. It includes 2 regions. Yeah, it's just an explanation, more explanation, but I got that. Let's see if the models will be able to solve. As I'm not able to run in parallel, probably, all the tasks, all of the models, all of the different models. In the composer, I'll submit only O1 mini. So for both parts, and you now can see that I will revert the changes that it's done to the first part. So they are clear. The first part is clear now, and O1 mini will try to solve both parts. Now, as we have this, we will uncollapse. Can we? Yeah. Yeah, it's already giving me a solution. So I can copy that to what other models we have. Anthropic models and GPT models. By the way, let's try also a O1 preview. So let's go O1 preview. This is the description of attentive code. Then we will have a description of the task. Solve both parts, okay. And let's submit it. Now we need to do the same thing to copy. Why don't you allow me to copy that? Seriously. Okay. I'll do it manually. So I'll be selecting Claude 3.5 IQ. So I've pasted in the description, and now I need a README. Okay. So we have a Claude 3.5 IQ solving it. Then we get O1 mini. Then we get O1 preview solution. And we also will be testing our Gemini. Where is that? So can I copy now this text? So both parts. To Gemini experimental 1206. What else? So Sonnet. Yeah. And GPT-4o, where is that? I'll be asking to solve. Where's my README again? Oh, have I pasted it? Oh no, I didn't do that. Or did I? Where's the README? I don't see it. But for some reason, how? Am I missing something? I don't see any description of the repository, how the project is organized. Oh, this is mine. Okay, so this was pasted as, okay, I see now. I thought it was discussing. I thought it's not mine, not my text. Okay, so I'm submitting to GPT-4o. This is Claude 3.5 IQ, and we should have a code here. All right, which should have a result from Gemini. Okay, and we should have something from O1 mini for part 2 and for part 1. Let's accept it and let's see the answer. So for O1 mini, yeah, again, it solved the first part, but for some reason it didn't do that for the second. Okay, so O1 mini is success for the first and failed for the second. Let's go with Gemini. Can I copy? Yeah, I can. What's the solve function? What's I'm sorry. Okay, so part 1, part 2, total part price part 1, total price part 2, area size. Okay. Interesting. So it's not the same way. Probably I forgot to paste the readme. Yeah, I didn't do that. Okay, let's try once again with Gemini. So I've actually forgot to paste the template. Okay, so both parts and do it again. Something is updated, has been updated about AI Studio. It was different yesterday. Okay, let's go. So, O1 Mini. Now let's Claude 3.5 Haiku, which I'm pretty sure it won't get a right answer for this one. But let's see. Haiku. No linter errors. Okay, there is some, but yeah, it's not important. So Claude 3.5 Haiku. Okay, there's a problem with reading input. I decided to change that. Excuse me. Okay, terminal. So Haiku. Okay, nothing has changed again. The answer is correct. 1446042. Okay, so the same answer for the Claude 3.5 Haiku. Now let's see what will Sonnet get us. Again, I need to copy this one. Start new chart with Claude 3.5 Sonnet, and also I need to attach a README. Okay. Well, actually, I could do that inside a composer, but yeah. So what do we left? What do we have left? GPT-4o. Let's see its solution. So here is the GPT-4o code implementation. Let's see if this one is correct. Yeah, input is not in this folder. No. GPT-4o. Okay, the answer is different, but it's not really different. Not different. Not very different. Where was I? Element of code, and we have an answer for the second part. It's too high. Okay. Yep. It definitely should have been lower. So we have an answer from Gemini. Let's see if it got it correctly. Gemini. Yeah, again. Okay. Gemini failed to solve the second one again. Let's feed the results. So on O1 preview we haven't seen yet. For GPT-4o, for O1 mini, and for Gemini. So all the models struggle with this second part. Let's see what Claude 3.5 Sonnet gave us. I wonder whether it will be a more correct answer. Let's see. Claude 3.5 Sonnet. Oh, yeah, I forgot about that. Okay, the answer is definitely lower now, and both the first answer is correct and the second is too low. Okay, but it's smaller. Okay. Interestingly, I'm not sure how to count that, but let's see. At least it's got a different answer for the second part. I will give it another chance. Retry. And let's see what we have from not Gemini, not GPT-4o, but from I didn't close. So let's see. Wow. Can you see that? Oh, sorry, it was included in the description. I thought it somehow solved the first part without the code. I forgot that I've included the answer. It's included in the description. Okay, so on preview. Hope is for you. There are some unused variables. Where's the input? File name read input. Okay. Let's see. O1 preview. Something is wrong. Something is definitely wrong. It shouldn't take so long. Okay, for the region cells we get some BFS again. Then we calculate the perimeter. I don't see how. Okay, part 2. Trace boundary. Region cells. Grid. Price part. Area. Price. Trace the boundary and count the number of sites. We'll use a modified boundary following algorithm. First create a set for quick lookup. Region set. Boundary, which is not used. Find the starting point, cell with boundary on its left, directions, direction names, again, not used variable, direction count, max row, max call, find the boundary cell to start. For region cells, we go for each cell, for I, the xdy enumerate directions, and x, if not outside of the grid, and or the next step is not equal to the step, then we go back to the start probably, yeah, and we break. So we like don't go in this direction. If it's not so, we continue. Then start boundary tracing. Why did we do that? What for? To find the start. Okay, so to find a boundary cell to start. Okay, boundary points. Previous direction x y. Visited boundary. Boundary points. Append. visited boundary, and it takes too long. I'm not sure it's supposed to be like that. Again, let's try Claude 3.5 Sonnet. The second attempt. I wonder if something's changed. Claude Sonnet. Okay, the number seems to be different. Let's see. It's too low. Okay. Alright. Okay, this one was low, and this one is even lower. I won't give Sonnet another chance for now. We tested out GPT-4o. We could try with GPT-4o Mini, but I'm pretty sure it will fail. But let's see if it won't fail at least the first part. So Sonnet is without points for the second, as well as the other models. GPT-4o Mini tries to... Okay, it tries to plan. Is it GPT-4o Mini? Seems like it's not so quick. Yeah, 4o Mini. Okay. In any case, grid example map date. Well, oh no. It didn't. I didn't see the readme. It didn't account for it. It was specified that I have a structure. Where's that? Notions. Oh, it isn't. Also, probably there's no information about the template. Okay. This is my bad. So GPT-4o Mini, let's see. In this. Okay, reading input. Okay, parsing map. Calculate regions. Okay, GPT-4o Mini is trying to solve something. But still, yep. So let's try again because we didn't get anything from the O1 preview. Let's try once again without prompting it additionally. So we get a result from 4o Mini. Let's see what it will get us. Okay, GPT-4o Mini. No, both are incorrect. Okay, both fail for GPT-4o Mini. Failed. So for O1 preview again, first is success. Second is... Oh, no. Currently, it hasn't solved any of those. So fail for GPT-4o Mini. Haiku failed to solve only the second one. GPT-4o the same. Sonnet the same. O1 Mini the same. Gemini the same. So for now, all of the models failed to solve the second part of the task. But the first part was only GPT-4o Mini failed. So we have something from O1 preview. Let's copy the code, set recursion limit. Okay. So something is definitely interesting here. By the way, it's trying to run it in threads for some reason. Okay, so let's firstly see if it runs. Okay, no inputs. Yeah, this is my bad again. Yeah, first one is correct. Perfect. Okay, success for the first part. Let's see for the second. But I wonder why it's so hard. Why do you need threading here? So now let's see how it tried to solve this one. So main, we get our grid, and get our number of columns and rows visited, which we create a list of visited what? Visited rows or something, region ID, directions, okay, regions map, identified regions using BFS, okay. So this is BFS apparently starting, okay, so for each cell, if not visited cell, then we check the plant type, we create a queue, we add the coordinates to the queue. Why do you... Okay, if it's not visited, we get the plant type, we add the coordinate. Visited, we check if it's already visited, region cells, while queue. So we go there. Then we go through this queue, which is currently only one element, but then we pop left, we append to region cells, then we go into different directions, we calculate the next move, we see if it's inside the grid, the end that we've not visited it, and it's the same plant type, the same letter, and if all are correct, then we set visited to true and append to the queue the next coordinate. So the current coordinate that we've checked. Therefore, what do we have? We then will have a region cells. Where do we do that? Okay, so after we've visited, after we count one region, like we store it in region ID. First region ID is 1. We get plant type, which is a letter, and we add all these region cells that is inside there. Then we go through the region cells, and we have a region map, which is what? I'm not sure. So we have some region map equals to region ID, and then we increment the region ID. So for the first part, compute perimeter. Let's see. For read in region items, area, length cells. So the first part is solved correctly. The second one probably not, but in any case, yeah, I want to see how the first part solution works. So perimeter 0. For x and y, so for coordinates in cells, for next move, dx dy in directions. Okay, so again, we go into different directions, and we try to go again the next, identify the next coordinate, and we check if again it's inside. What if it's inside? Yeah, if it's inside a grid, and then the next value is not equal to read, which is what? What is region items? Read and for read is region ID. Read is region ID. Okay. So for region ID is not, if the region ID is not the same, we add to the perimeter. Price is area multiplied by, so it's after we do all that, we get a price of this region regions, region ID area, we set the area key to the area, we set the perimeter, and we set part 1 price. Then we compute the number of sites. And this one works incorrectly, probably, by the way, because it has again some unused variables. Probably it should have used it. So if not boundary pixels, single cell region, number sites, and yeah, it starts the main function inside the thread for some reason. Okay, so it seems like the second part is incorrect. Did I? Yeah, it was the second attempt, and because no model has still solved the second part, I will prompt it with I will prompt it additionally. So the second part would never stop, and what I see there is those are unused. Also, some variables are unused for some reason. These ones. Check your solution and logic once again. This is O1 preview. Then we'll go to the Sonnet solution, and let's see Sonnet, and let's say that the answer is too low. Again, we'll prompt Sonnet again, because again, no model has solved the second part, so I will try to help it. So I would say the part 1 is correct. Part 1 is correct. The part 2 is too low. Revise your logic of counting sites. And let's see. Okay, and close GPT-4o. O1 preview. Still thinking. Nice. Still thinking. Okay. Let's see. Doesn't allow me. Okay. So absolutely correct. Issue explanation: while loop in the boundary tracing part 2 didn't properly update the traversal direction termination condition, which would cause the loop indefinitely. Variables chain, dir map, and dir map ref were defined but not utilized. Okay, solution will correct the boundary tracing algorithm in part 2 by properly implementing Freeman chain code method. Okay. This method allows us to trace the boundary of a region and count number of sites by tracking the direction changes. Okay. Let's copy. Again, why do you use threading? O1 preview. Oh yeah, I forgot that. Okay. Apparently the answer is too low again. Because yeah, I just don't remember exact number, but let's see if this one is correct. No, yeah, this is not the right answer. Do you start using full input data? Because you guessed incorrectly 4 times on this puzzle, please wait 5 minutes before trying again. No problem. So again, this one was incorrect. from O1 preview. Let's see what Claude gives us. Let's see the comments. Let me review the revised part 2 logic. Create a new count size revised function that separately tracks horizontal and vertical edges. For each cell in the region, checks all 4 sides, adds edges to the appropriate set when they are boundary, count an edge when it's either a grid boundary, add a grid boundary adjacent to a cell, but not in the region. Main difference between the previous version is more precise edge tracking for both horizontal and vertical edges, better handling of internal boundaries, proper counting of edges that form corners or complex shapes. Yep, let's see. Again. Claude 3.5 Sonnet, and in the input is no, nothing. Like, I wanted to solve that. It's okay. So it's like it was like 3 attempts now. Both O1 preview and Claude 3.5 Sonnet weren't able to solve that. I will try to prompt it further. So, no, the answer for both parts is the same now. It's incorrect. I won't be trying, or would I? Okay, let's try O1 preview once more. So I'm just adding a prompt again. Now the answer, now it goes outside of the loop, but the answer is too low. Think again. About the task description. Okay, let's see. Okay, so this is the updated version of Claude 3.5 Sonnet. Input 3.5 Sonnet. The answer is the same now. No, the answer is still the same. Okay. O1 preview is still thinking, and I can try O1 mini to prompt it further. Garden groups. So let's go into O1 mini. So we have this description, and then we had a template which I am supposed to paste over there. Where's the editing button? Why can't I do that? Okay. Let's create a new chat with O1 mini and let's paste it. Okay, we have something. So let me try a different approach. And the key insight I was missing in the part 2, we need to count the number of straight line segments that make up region's boundary regardless of their length. Yeah, this is what you're supposed to do from the beginning. Again, input, and the answer is different. It could be still incorrect. This is too high, but yeah, this is not the right answer. We've guessed incorrectly 5 times, and we need to wait another 5 minutes. Okay, what do we have left? So, one preview, the latest answer. Let's firstly check the description. So, correct approach. After my, yeah, so it goes outside. No, the answer is too low. Haven't I prompted once more after that? No. So let's see. Understanding the problem for part two. For part two, we need to calculate number of sites, straight fence sections for each region, not just a perimeter. So it's trying to analyze this sample input. Region A has 4 sites. Region B has 4 sites. Could be. Let's. All right. Could be my bad that I haven't, like, you can see that the formatting is not correct here, so that these parts are not parsed properly. So yeah, let's try it again. And now it will able to see the pattern, because there are spaces between those. It actually should have been like that. Let's see if it helps to understand the solution. Yeah. ABB, so yeah, okay. It still is not perfectly correct, but it was thinking 100 seconds, and the output is like reasoning tokens are 7,000 tokens. Okay, so let's start again. So both parts. Let's see what I've got from. So the description for O1 Mini is correct. Let's see if the code works. O1 Mini. Okay. O1 Mini. So the first part is correct. The second one is lower than this one. So this one, it was 68,000 and it was too low. 40,000 is lower. No, the answer is still the same. Did we try to run this one? I can't remember. Oh, yeah, probably yes. But I run it anyway. Yeah, the answer is incorrect. Let's see what we got from the O1 preview. Yeah, if it's not able to solve, why do you have so few, like, not a lot of code there. Okay, O1 preview. Now it's not using threading. Again, direction mapping. It created it, but it hasn't used it. Hasn't used. O1 preview. Oh yeah. Again, it's stuck in a loop. Why? Why does it make the same mistake? No. It's stuck in a loop. Seems like this is the first part, the first task that is unsolvable by those models. By all of the models. We've tried Gemini. We can also try Deepseek. Deepseek. It's a Chinese model that apparently thinks as well. Yeah, we can start now. We can use a chart with deep thinking, and we need to insert the same. So this is O1 mini. Sorry, I've forgotten. Yeah, so O1 preview failed. O1 mini failed. I need just a description for Deepseek. And you can see it's thinking as well, but the thinking process is not hidden from us, and apparently it's not in the same format as OpenAI's type of thinking. Like they will give us only a summary of the parts is thought about, but here it is. It's just thinking as in a text, like. Describing a concrete process. Let's read it.
This is getting too vague. I need a better approach. Maybe I can think of the fence as a polygon and count the number of edges. But the grid is discrete, so it's not a continuous polygon. I need to find a way to count the number of straight fence segments based on the grid. Alternatively, maybe I can use the perimeter and area to calculate the number of sides. Wait, in part 2, the total price is area multiplied by the number of sides. In the first example, region A has area 4 and sides 4, so price is 16.
I like how it's thinking.
But earlier it was area multiplied by perimeter. I need to make sure I'm interpreting the problem correctly. Looking back at the problem statement, in part 2, the price is area
Okay, yeah, in the first example, I need to find way to count number of straight fences. That's just repeating the same thing. So in code, I need to read the grid, identify all regions using BFS or DFS. For each region, calculate an area, calculate perimeter. For part 2, calculate the number of sides traversing. Yeah, all right. So we have some solution. Let's see. We'll need to add a new file. We'll call it Deepseek Py, and reading input from the directory above, and let's run it. The number is smaller, but is not too small. No, this is not the right answer. Okay. So yeah, I'll say that we'll consider this as fail day for the AI models. It's day 12 and no model was able to solve the second part. Even though I'm not sure how would I approach this problem, but it's definitely not so problematic, apparently. I'll see what other YouTubers who are solving the advent of code as well. I'm just interested of how they solved it. So this is it. This is it for today. Let's see if we get to update our results. Yeah, let's say success for the first part and failed for the second. I probably won't be including Deepseek solution. No, I can include it, but I won't count it in our results. So let me submit the day 12. No. Add solutions for day 12. Okay, yeah, this is it. And yeah, in case you're just wondering, I will be watching a YouTube video and reacting to it.
Welcome to day 12 of the 2024 Advent of Code. Today's is another grid problem.
It's part 2.
This time we have a garden.
Yeah, this is one.
Moving on to part 2, it looks like we are eligible for a bulk discount here. And instead of using the perimeter to calculate the price, we use the number of sides.
Yeah.
Area times the
this is
center point here.
We
Is
get
that a bit
this.
better in this area here? So to visualize that a bit better, let's suppose we have a garden that looks something like this, where the middle region is not part of the garden. Then this is not one edge. So let's work backwards here. I have two solutions here. This is going to, the first one I'm presenting is going to be the one that I came up with during the contest, and the second one is one that I have not tried whatsoever, so you will get to experience the debugging process together with me. So looking at the edges, we can see that this one has 12 edges. In order to determine this, we need to note that because this does not count as one edge, then it follows that we need to track which direction each side is facing. So if we mark the side that is not part of the garden with red, then this is what we have now. And so these are the individual sides. We see that we drew 12. And now if we are to separate these into individual squares again, like they were previously, then we can see that we basically have a bunch of individual edges, each edge having a direction. So how can we determine where all of the edges are? Because these interior edges do not count. So we can use a sort of half Cartesian coordinate system. So if we imagine a coordinate system, which we already conveniently have because we're operating on a grid, let's suppose that these cells have the following coordinates: 1, 1, 2, 1, 2, 2, and 1, 2. It stands then to reason that realistically we could indicate the coordinates of an edge based on the two squares that it sits between. And so we can give this a coordinate of 1, 1.5. Basically, we take the average of the two squares that it touches. This one can have a coordinate of 1.5, 2. And we can see that intuitively this makes a lot of sense. 1.52 means that it sits at y equals 2, which means it sits along this slice where the blocks sit And 1.5 means that it's to the right of the 1 column where these sit, but also to the left of the 2 column where these sit, meaning it's the edge between the two.
Not
Continuing
sure I
that
got it.
logic, this edge becomes 2, 1.5, and this edge becomes 1.5, 1. Now, under this system, we could also represent corners by just looking at all 4 of the squares they touch and averaging them all out, which gives us 1.5, 1.5, but that is not currently relevant. So let's get rid of our perimeter function and let's look for the side count given a region. So in order to determine the number of sides, we're first going to need to get all of the edges. To get all of the edges, what we're going to do is we're going to look at each square and look at all 4 of its edges again, just like with perimeters. But what we're going to do is, if we, instead of adding 1 to the perimeter count, if we see that the neighbor 1 exists, we're not going to add the edge. Otherwise, we are going to add the edge, making note of which direction it's facing. For consistency, I will mark the facing of an edge as the direction from the edge towards the center, or towards the square. What that means is this edge, if we consider this edge here where this square is where the edge originates, then it would have a facing value of negative 0.50. What this tells us is that it is facing leftward in its row, and it is not
Apparently, I don't quite understand why do you have these 0.5s. Where did you get that, and how do you implement the facing direction there to keep track of the facing, where the side is facing? But I would like to see what I would like to see, like O1 preview now, Deepseek. Let's see O1 mini solution, and let's see. So what did it do? Pop left. Oh, what was it? Was it giving me the same answer on mini? No. So it was closer than the other models. So ILQ, pop left, regions, append 4dx into y in and x. So if we visit it, if it's not visited and it's the same plant type, we add them to visited and add them to queue. Count straight lines. So how do we count straight lines? Grid and region cells. We have quite a bit of description here. Simplify, calculate numbers, perimeter cells, that starts. Each time fence changes direction, it's a new side. We'll track visited perimeter cells, avoid recounting. So again, we have perimeter, unused variable, directions, region set for faster lookup, which is not used. Perimeter cells, find all perimeter cells. For all directions, we get the next direction. We check if it's inside, if the plant is the same. Plant. So perimeter cell we add if what? Perimeter cells. So we just, okay, so we continue moving. So we just continue moving if it's not. So what this condition is about? If next x is bigger than 0 and less than grid, and this one, then or the plant is different, then we add xy, so not the next one, but the current one, to the perimeter cells. If none, we return 0. Then start traversal from the first perimeter cell. Start next iteration, perimeter cells, current start, previous direction, visited perimeter. While true, visited perimeter at current, xy current, find direction. For idx, dx to y in the right direction. So again, we go all the directions. We try to find if next cell is in perimeter cells direction. Then if direction changes, then sides plus 1, previous direction. So yeah, I think it has the same problem as he described. That in our solution currently, it counts. So if we have this region and this region are separate, then it not separate. If they are the same, so here we have A, here we have A. These are separate regions, but it could count them as one because it would go this like it will not change direction and goes and will go further down and count this as one side. This will be an incorrect one. So we go in perimeter cells, direction. If direction changes, then we add sides, previous direction, current, front direction. Sorry. Perimeter cells. So we get perimeter cells, which is added here. We go into all of the directions, and we need to check if the region is the same somewhere over there. Region cell, region set, region cells. For xy and region cells, I will do it manually. So yeah, seems like it was what I wanted. So if an x and y in region set, then we again break out of this one. Yeah, the answer is different, but it's still lower than we need. So probably this is not the only thing we need to change. We have an answer from O1 preview, which is not, yeah, it's just stuck in a loop. Oh, by the way, have we asked it? Yeah, I think I've asked it. Yeah, it's stuck in a loop. Okay, O1 preview, last chance. Yeah, last chance for you alone. O1 preview. Again. So I have an input. Yes. It should be lower. No, it's not correct. Okay, let's see what it gives us for the part 2. Calculate prices. Total price part 2 for region in regions. Compute perimeter and size. It's just doing its own in one. Okay, again, cell set, which is not used for some reason. If it's not in grid and this one, or NXY in cell set, on preview. Not as it's not. It's incorrect. Why? Can I do this like or not in cell set? No. No, it doesn't matter now. So cell set region cells, size, concise. How do you count the size? Sides, direction vector, direction indices, direction map. Use left-hand turn boundary tracing algorithm. Sure, always traverse the boundary as a consistent manner. Will simulate the movement of a turtle on the grid. Yeah. This seems like a correct approach. Try to turn left, counterclockwise. Turn false. So we have marked steps to break to prevent infinite loops. Steps visited. Current direction. DXDY minus DXDY. Rotate counterclockwise. If next in boundary cell set. Boundary set cells. Cell set. Boundary cells. We accept it. Yeah, unused variables. Can't move boundary, tracing complete. So the answer is too big now, too large. So something is definitely wrong. I can't see the correct the problem we're having. So yeah, I'll be finishing on it. This was a bad day for AI models. Bad day for me as well, because I haven't finished the second part. And if I return to the 2024, it won't be colored with nice fancy colors as it was before. Okay, so it's either I'll be solving it myself, or I can do what? Let's do, you know what? We should have something, some code probably. No, it's become a partner. Okay. Code crafters. Do you have a code? No, you don't. Let's find so 2024 day 12 Reddit solution advent of code. Advent code, so Reddit. Okay. There are some nice fancy memes. So day 12. Almost no overlap between part 2 and part 1, part 2 leaderboard. LLMs might have found their limits. Yeah, this is the... Yeah. Okay. So seems like... Let's see the leaderboard. leaderboard. So we should have like personal times. No, it's not that. What can you? Shall you appear here? No. Where is the timing? Okay, per day. Okay, so we got first 100 users to get both stars on day 12, and we have the smallest time is 6 minutes, and yeah, 6 minutes, and by first star is so these people are apparently using LLMs. Because 14 seconds, no way you can read the task and solve it in 14 seconds, in 15, 16 seconds. Like under a minute, I'm not sure, but definitely not under 13, not under 30 seconds. And let's see for the... Oh, not for the... Okay, so we can see the timings for the second star, but we can see the both stars. So even though we have 6 minutes for the second, like for both parts, it's not like it's 5 minutes only. It's around 5 minutes to solve the second part. So probably probably no LLM was able to solve the second part. And this, by the way, would be really interesting to benchmark the newer models on. So this part. So remember, till day 12, part 2, we can just copy and try LLM to solve this part. In order to understand whether the LLM is actually good enough. So yeah, 171st star. And the solution for both parts for the top leaderboard is under like from 6 to 17 minutes, which quite a bit. So yeah. Yeah, someone has built a visualization. Nice fancy thing. Wow. Do we have a solution? Plotting the gardens again. Visualization. It won't. Oh, okay. Not so good, but all right. It's like counting in real time. Code is on GitHub. Okay, so we have a solution here. Is it only no, it's full day. So what I'm going to do now is to show one mini the solution and say no, you've solved it incorrectly. Here is the correct approach. Please describe what you did incorrectly and try to fix your code, not just copying their solution. And I'll do the same for Claude 3.5 Sonnet. I'll be closing nothing. Let's see what Claude will say us.
Main error in my solution. I was counting sides based on boundaries between cells, similar to part 1. The key difference is that in part 2, we need to count actual straight line segments that form the boundary. My approach didn't properly handle cases where multiple cells form a single straight line segment. The correct approach from the provided code: for each direction, up, down, left, right, find all boundary cells in that direction. For each direction, when finding boundary segments, create a set of all boundary cells in that direction. Remove cells that are part of the same straight line using the perpendicular direction. This ensures we count each straight line segment only once, regardless of its length.
Okay, so apparently it did the first part, like it created a sets of boundary cells and other, but it didn't remove it later. Create new count distant sides, blah blah blah. It won't count as a correct solution because we just gave it input, but let's see if it was able to apply it correctly. Yeah, this way I will cheat and get the second star and submit. Yeah, all right, so the answer is correct now, and this one is colored nicely. So let's see at the diff. So letter, we remove letter, or greet and C is not equal to letter. So we to calculate the perimeter. Why do you change that? Okay, to calculate the perimeter of a region. Seems like it tried to fix itself the part 1 as well. Count straight lines, count distinct sides. Okay. So it's completely removed and rewrote this function. Okay, so it's not like applying it to the previous solution. But let's see what is the correct one. So solve part 2, distinct sides, and let's see what are these interactions. Boundary. Let's first find all boundary cells in this direction for R and C in region. So get on region of a plant, adjacent row, adjacent column, a row plus dr, column plus dc. If adjacent is not in region, we add it to the boundary. Not adjacent one, but the current one. Remove cells that are part of the same straight line. To remove, so we go removing for R and C in boundary. Check perpendicular direction in row for row and column. Swap and use as a perpendicular direction. Check position. While check position in boundary. To remove, add. Check position. Add count of distinct segments in this direction. Total sides boundary, length of boundary, minus length to remove. So what? Okay, so the approach apparently is such that you still count all the segments, all the boundary, but then you additionally count the sections to remove from that. And then you just subtract it. Subtract. Okay. Seems like understood now. Let's see the O1 mini. What does it say? So, the initial approach, part 2, was largely correct. It involved blah blah blah. However, there might have been minor inefficiencies and inaccuracies in handling edge cases, especially concerning grid boundaries or overlapping regions. Okay, no problem. Part 2. Total fence using number of sides. Primary issue was the method we used to calculate number of straight lines. Of straight fence sizes.
The initial solution attempted to approximate the number of sides based on perimeter cells, which did not accurately account for the actual number of straight segments. This led to incorrect calculations, especially in more complex region shapes. Why it was incorrect approximation instead of accurate counting? The initial approach approximated the number of sides by considering perimeter cells, leading to inaccuracies in regions with complex boundaries. Direction changes not properly handled. The method did not accurately track direction changes, which are essential for counting distinct straight sides. Edge cases overlooked. Regions with internal voids or multiple adjacent regions were not handled correctly, causing miscounts in the number of...
Okay, I see now. It could be correct now, but can you create a hint for yourself? A very short one, like in 1-2 sentences. Says to help the previous your version of yourself, like previous state, to help to solve this part 2, not stating what's incorrect, but just adding to the task description. Let's see what's got. So when calculating the number of straight fence sides for each region, ensure you accurately trace the perimeter and count each distinct direction change. Alright, so I will do the same for Claude 3.5 Sonnet, and I will try to prompt this at this small hint at the end of the prompt. So it's the same thing, just when calculating the number of straight fence sides for each region, you accurately trace the perimeter and count each distinct direction change. It seems like nothing is added, but yeah, it's what O1 Mini would suggest to itself. read input. Yeah, input is correct. O1 mini. Yeah, it's not correct. Okay, let's see now what will Claude give it to itself. When counting sides for part 2, think about how many separate straight pieces of fence you need to physically construct the enclosure, rather than counting cell by cell boundaries and a continuous straight line of 5 cells need just one fence piece, not 5. Yeah, seems like it's not suggesting it an answer. And let's try it again with a little hint. I will do the same thing for O1 mini, because it could just fail to identify the correct hint for itself. Yeah, what do we have now? The solution handles both parts. Part 2 counts actual fence segments, continuous straight lines will count as one side. Okay, yeah. So solve input. Let's see Sonnet. This was the incorrect one. Yeah, we should have like 900 to 1000. So yeah, an answer is still incorrect. Let's see what one mini gets us. And again, incorrectly. Well, the answer is different now. It's always different. There's missing something. So I would really like to see if we are able to prompt it just with one, without actually revealing their solution, but prompt it properly, so it will able to solve this one. So no. Here is the correct solution. Identify a hint for yourself so that we can prompt you again without revealing the actual solution. And you're able to solve this part 2. Part 2 is incorrect. So looking at the solution code, notice key difference, how sites are counted, part 2. Critical hint is in the code approach counting sites. Key insight I missed about how probably count orthogonal fence segments. My solution was overcounting by not properly identifying continuous straight lines. Yeah, when counting sites in part 2, think about how to handle perpendicular connections. Yeah, this is the thing that was described on the video we've seen. So for each direction up, down, you need to identify and remove the cases where it looks like a new site is actually a continuation over existing fence. Yes, but it Seems like you are giving a solution, a part of a solution, not a real hint. Okay, when counting sites, think about actually building a fence in real life. What directions would you need to walk around in the region and place all the fence posts? Focus on the key compass directions and how corners work. Probably this won't help it, but let's try it anyway. So, yeah. Let's see, and this should be it. I won't be doing anything else. I won't be trying more input data main. Why? Okay, let's create a reading input function. Claude 3.5 sonnets. Now, main. So part 1, part 2, find regions, on sides. Seems like it's stuck in a while loop again. I would really like to find an answer, so at least some answer from that. And the code, by the way, is not really readable. It's again using like those RC. Why won't you name it correctly? So to use this solution, it suggests me running it like that. Okay. Again, the same thing. It just stuck in a loop. Okay. So, final results. I'll be stopping like right now. Final results. No LLM, even with the additional prompting, even with hint that suggested the approach it should find for the solution, it wasn't no LLM was able to solve the part 2. This is interesting, and as I said before, you can try to then benchmark other models, because all of them failed to solve the part 2. We've tried Claude 3.5 IQ, Claude Sonnet, Deepseek Chinese model, Gemini 1206 experimental smart model, GPT-4o mini, GPT-4o, O1 mini, and O1 preview multiple times with hints, and no model was able to solve this task. Yeah, so this is it. Thank you for watching, and I hope you have a good day.